Well, welcome back to GIS Analysis at the University of Alaska Fairbanks. This week we're going to start working with the analysis of lines. And there's a couple common problems with lines that we'll discover in this video session. So what is a line? A line is a feature that has length and no width. And it has a starting and ending point called nodes, beginning node and ending node. And because it has a starting and ending point, it has direction. Let's start by making some test lines using the Create Fishnet geoprocessing tool. And we'll start with an origin 0, 0, and we'll go straight north. And we'll have one row, one column, which will essentially create a square, and the square will have a dimension of 10 by 10. And then the type will be geometry type polyline. So the output results in 4 lines, and the question is, what's the direction of these lines? And the direction is important. For example, if you have lines representing streams and you want the lines to flow downstream, or you have lines representing roads and some roads are one-way roads and you want the direction to represent that one-way direction of these one-way roads. So the easiest way to find the direction of each line is to symbolize it with an arrow at each end. So if we go to our layer properties and then symbology, we'll change the symbology. We have an Esri symbol set, and if we scroll down, here we have arrow at end. So that will put the arrow at the end of each line. So here is the direction of each line, and the direction is called the topological direction. So for example, since this is the direction of this line, this is considered the left side of the line, this is considered the right side of the line. And since this is the direction, this is considered the left side of the line, and this is considered the right side of the line. So with certain tools, when you say left side or right side, it actually refers to the topological direction of the line. So for example, let's try a buffer tool, and we'll buffer on the right side of the line. So here we'll buffer our lines by a distance of 2, and we'll choose only do it on the right side of the line. So the topological right side of this line is this side because the direction was left to right. You can easily change the direction of the line by selecting whatever lines you want to flip. So I'll do lines 1 through 3, and then we want to change the direction of these 2 lines. So to do that, we'll run a geoprocessing tool called flip line. So if I say show help, this tool reverses the line from the 2 direction of line features. And it also tells you you can view the lines by symbolizing lines with arrowheads at the end. So we'll take our test lines and then flip them. So after the tool is executed, we'll clear our selection. So now we have these 2 lines are flipped. And if we run our buffer on the right side of each line, so it buffered on the right side of each line. And I'll change my symbology back to some other symbol. Next, we'll create a second layer of test lines. And what we'll do is we'll change the origin. We'll go 5 in the X and 5 in the Y. So we'll have a square in this area. So we can use the Create Fishnet tool, and we simply change a couple parameter values. So if I go to Results, Create Fishnet, we'll name our output Test Lines 2, and we'll start at 5, 5. And then we want to go straight north, so we go 5, and then any value that's greater than 5 to go straight north. So I'll just arbitrarily pick a value greater than 5 in the y coordinate to go straight north. And then just OK. So now we have 2 layers of lines. And one question is, where are the intersection for these two layers. Remember, I said that lines have length but no width. So let's try the intersect tool and see what happens. So we're going to intersect our two layers and we get a warning. So if I go back to results, under messages, here's the warning: empty output generated. So the intersect tool could not find the intersection between these two layers, so there is an empty output. And the reason why is lines have no width, so since lines have no width, there is no intersection between these two lines in terms of a line because the width is 0. So the solution to that problem is we have to say, give us the point where these two lines intersect, or the location where these lines intersect. So to do that, we can rerun our intersect tool, and down at the bottom, the output type, change it to point. And that will output where the lines intersect, what's the location. So after executing the intersect tool, we have the location where lines intersect. The points will have all the information about this line will be in the point attribute table for this point, and all the information from this line will be in the point attribute table for that point. If you run the spatial join tool with intersect, you'll get a different result. So basically what spatial join will do is find wherever our test lines intersect with our test lines 2, and then return the information, for example, from this red line, return that information to this purple line. So to make this clearer, let's add a field to our test lines, and then we'll calculate this field to be object ID plus 200, or something arbitrary like that. So what we want to do is use spatial join, and then we'll label our red lines with the test line ID. So if we go to our red lines, properties, labels, let's label them using the field test line ID, and it will be a red bold color. So now we've got our test line IDs. So we could use spatial join to transfer 202 to this line that intersects, and to transfer 204 to this line that intersects. So the intersect in spatial join is very different than the intersect in the intersect geoprocessing tool. So we run the spatial join tool where we're transferring information from our test lines to our test line 2, and our match option is intersect. So the result are the exact same lines as test line 2, except we'll have all the attributes from test line 1 if the line intersects. So then if we look at our attribute table, this line intersected with successfully, so it found one line that intersects. This line intersects successfully, it found one line. This line, there was no intersection. This line, there was no intersection. So we get all the information about the intersecting line. So for example, this line we know intersects with our test lines, and the original test line's ID was 204.